These are the solutions to your geometry review sheet. Be sure to use a grading pen and fix any answers that you might have missed, including the correct steps on how to get each answer. You must have the correct answers and the correct solution shown in order to receive full credit for each problem. On number 1, we have a scale drawing of a floor plan, and the scale that we're going to use is 50 inches is going to be equal to 1 inch on the floor plan. I'm going to set that up as my first fraction in the proportion in order to convert the dimensions that are on the scale. So 50 inches represents the real life distance, and 1 inch represents the scale drawing. So on top, I'm going to write the actual over the scale. And that's just going to help me keep everything lined up when I set up each proportion. I'm going to begin by just converting the 2 1/4 inches. Personally, I prefer to do this in decimals, so I'm going to convert 1/4 into 2500. So I'm going to write this as 2.25 inches. That is clearly going to be the scale because you can't have a bedroom that is 2.25 inches wide. So I'm going to line that up with the scale in the denominator and do 2.25 inches. And then in the numerator, I'm going to put the variable. These two measurements represent length and width, so I'm going to put W for width. Now I can solve using either cross products or scale. For this one, I'm going to multiply by 2.25 on top and bottom. And that'll give me the value for W. So I can set up 2.25 multiplied by 50. And when I do that, I get 112.5. This is still going to be in inches, and that's going to represent the width. Then to find the length, I can do the exact same thing. I'm still going to start with my same scale factor and set up a second proportion. This time we're going to do length, and we're going to convert 2 3/4 inches into 2.75 inches. So that'll still be lined up in the denominator. Then I can use my scale factor of 2.75 and multiply on top and bottom by the same number. So we can set up our multiplication, 2.75 multiplied by 50. This time I get 137.5 inches, and that's going to represent the length. So my final answer, under dimensions, that just means what's the length and width. I can write that the width is 112.5 inches and the length is 137.5 inches. Then when I get to part B, it asks me for the approximate dimensions in feet. It also tells us we can round to the nearest foot. We're going to do all the math, and then at the end we'll round to the nearest foot. So I need to use these same numbers that I just got in part A. And this time my scale factor in blue is going to be the conversion between inches and feet. So I can set up 12 inches over 1 foot. And I'm trying to convert it into feet, so that's where my variable will go this time on the bottom. And we're going to use the 112.5 in the numerator. This time we're going to use cross products since there's not a nice easy scale factor we can use. So I'm going to multiply 12 times W to get 12W. And then I'm going to multiply 1 times 112.5, and that's going to be the other side of my equation. Remember, the entire point of doing cross products is to set up an equation that you can then solve. So we're going to divide each side by 12. And when we do that, we're going to put 112.5 inside the box and 12 on the outside of the box. You can see the steps for division in black. When we do that, it comes out to 9.375. Because we're rounding to the nearest foot, we're looking at this 9.3 part. Anything under 5, so 0 through 4, we're going to round, keep it at the same value. So that tells us that our width, we can round it to be 9 feet. And then we're going to do the same thing for the length. We'll use our same proportion, except this time we're going to put in L for length. And then we're also going to use our measurement from part A, which was 137.5 inches. So again, we need inches to line up with inches in the numerator. And then just like before, we can use cross products. So I'm going to multiply 12 times L, which is going to give me 12L. Then I'm going to multiply 1 times 137.5, which is going to be 137.5. Again, I'm going to put an equal sign in between to set up my equation, and then divide both sides by 12. So 137.5 goes in the box, and 12 will go outside of the box. If you were to divide this one all the way out, you would actually end up with a repeating decimal, so you'd get 11.458333, on and on and on. But just like before, we really only care about the tenths place. So in the number 11.4, that tells us we're going to round to 11. So that's going to be a length of 11 feet. And I'm going to get rid of this so I can write my final answer in the box. We have a width of 9 feet and a length of 11 feet, which seems pretty reasonable for a bedroom. Then for our final step, we're going to find the area of the bedroom. So area of a rectangle is just going to be length times width, so showing that 4-step process. Then the length was 11. Remember, we're using the rounded numbers. The width was 9. And that's going to give us a total area of 99 square feet. So we're going to put feet with an exponent of 2. So again, notice how area is square feet and length and width are just regular linear feet. Okay, next we're going to draw a triangle with 2 angles that measure 35 degrees and 55 degrees, and then one side that measures exactly 4 inches. I'm going to begin with my side length of 4 inches. So using my ruler, I'm going to measure out 4 inches right there. Then, once I've measured that line segment, label it. That way it's easy to tell which piece of the triangle is what. Then I'm going to line up my protractor on one endpoint. I need to be able to see the endpoint through the hole on the protractor. And from this line right here, I'm going to count up to 35 degrees. So I'm going to count up 10, 20, 30, 35, which is right here. I don't necessarily need to draw in that part of the line, but I want to make sure you know where your dot will go on which side of the protractor. Okay, then you can move your protractor out of the way and connect those. Be sure to use the protractor to get a really straight line. And then right inside the vertex, we're going to label that 35 degrees. And then next, we're going to move our protractor to the other endpoint of the line segment we drew. And this time, we're going to count up the opposite direction. So here's 0, and I'm trying to get to 55. So I'm going to count up 10, 20, 30, 40, 50. 55 is going to be right there. Okay, just like before, I'm not actually drawing that in, but I'm just using my finger to count. I can then twist the protractor around and get a straight line for the 55 degrees. And then we're going to label 55 degrees right inside the vertex. Be sure to check your angle measurements. If it's less than 90, you should be drawing an acute angle. If it's greater than 90, you should have an obtuse angle. And then finally, I should do a quick check to make sure that the third angle adds up to what it should. I know that all the angles within a triangle should add up to 180. So let's just check 35 plus 55 adds up to 90 degrees. And so then when I do 180 minus 90 degrees, my final angle should be right at 90 degrees. So we can test that by using the protractor, flipping it around, and when we line everything up, we can look right here and see that that line does cross right through 90. And so let's label the final angle 90 degrees, and we can be sure that everything matches up like it should. Number 3, you've seen this question on your quiz. We have angle A that is 2x plus 40. Angle B is supplementary to angle A and measures x plus 20. And I take that back, you've seen a problem very similar to this on your quiz. Let's first start with supplementary. Supplementary, if we have the S for supplementary, we can use our little trick and show that that equals 180 degrees. Just as a side note, complementary adds up to 90 degrees. So you can actually see the letter C and S within the 180 and the 90 degrees. So just to remind us, let's write 180 degrees next to supplementary. These two angles need to add up to 180. So I'm going to take my first angle, which is 2x plus 40, and then I'm going to add the second angle, which is x plus 20, and all together it needs to equal 180 degrees. From here, I'm going to combine like terms. 2x plus 1x equals 3x, and then 40 plus 20 equals 60. From there, bring down the rest of your equation, and we can solve for x. The opposite of adding 60 is subtracting 60. So that's a 0 pair, and we're left with 3x equals 120. And then we're going to divide by 3 to get x equals 40. So we'll put x equals 40 on the line. Don't necessarily need units just yet because that's not an angle measurement yet. On part B, that's where we're going to use it to find the angle measurement. So we'll do angle A in blue. So I'm going to start with 2x plus 40, or 2 times x plus 40. I know that x is equal to 40, so I'm going to put in 2 times 40 plus 40 and simplify. So that's going to be 80 plus 40, which is equal to 120. So angle A is 120 degrees, and we do need units for the angles. Then let's do angle B in red. So I'm going to start with x plus 20. And since x equals 40, I can substitute 40 plus 20 to get a final angle measurement of 60. And just like before, we're going to put degrees. Okay, final check to make sure we've got the correct answer. Both of these angles should add up to 180, so let's just make sure they do. 120 plus 60 does come out to exactly 180 degrees, so I can be sure that I've got the right solutions. Okay, next, number 4, a picture is copied onto a sheet of paper that is 10 inches by 12 inches. Let's label our picture. So the longer side needs to be the 12-inch side, and the shorter side is going to be 10 inches. It says there's a 2-inch margin all the way around. So this is 2, this is 2, this distance is 2, and that distance is 2. If we're starting with the length, that's this total distance, but I have to take out this length of 2 and this length of 2. So that's really just going to be 12 minus 4, which is 8. So the length is going to be 8 inches. Then for the width, I'm starting at 10, and then I'm taking out 2 sets of 2, that 2 and that 2. So 10 minus 4 is 6. So the width of the picture is 6 inches. Then from there, kind of like the first one, we can find the area by doing length times width. So that's going to be 8 times 6, and a total area of 48 square inches. Again, notice how the units change to square inches when I find area. Okay, on number 5, this has to do with the triangle inequality theorem. So if you remember when we used the strips of paper to see if we could make triangles, that's what this one is asking about. The triangle inequality theorem told us that when we add up the small side plus the medium side, that needs to be greater than the longest side in order to get a triangle. If you have it less than or equal to the long side, then you won't get a triangle. So for part A, let's test and see if this works. We're going to add 3 plus 3, and we need to make sure that that is greater than the third side of 3. 6 is greater than 3, so that means we do get a triangle. This is actually going to be a specific type of triangle. If all sides are exactly 3 feet, that's going to be an equilateral triangle. So we can use that to write in our answer. So for my explanation, I said the small side added to the medium side is greater than the longest side. I would encourage you to also include the math part that goes with it. That'll give you further justification. All right, part B, we have side lengths of 4, 6, and 10. So I'm going to test to see if 4 plus 6 is greater than the longest side. And 10 plus 10 is not greater than 10. If the two smaller sides are equal to the largest side, you end up with a straight line instead of a triangle. Therefore, you will not get a triangle. So we're going to say no triangles for that one. For our explanation, we can say the small side added to the medium side is equal to the longest side, therefore it would be a line instead of a triangle. Okay, moving on, number 6, circle the sketch of the cross-section of a rectangular pyramid that is cut parallel to its base. So because I'm looking for a rectangular pyramid, I can automatically eliminate the rectangular prism. Parallel means that the two lines do not intersect. So when I look at these cross sections compared to the base, I want the one that does not intersect. And so when I trace it, I can see that that's going to be this one right here. Just as another vocab check, the word perpendicular means that it intersects at 90 degrees. So even though the first one is not parallel, it is perpendicular. Then we can write in the shape of the cross section is, and all we know that this is a rectangle, so we can write in rectangle. Number 7 is a check on your formulas. You will need to have these formulas memorized. So if you need to make flashcards or quiz a friend with them, go ahead and do that. Area of a triangle is base times height divided by 2. Area of a circle is pi times radius squared. The circumference formula, there are actually two. You have pi times diameter and you have 2 times pi times radius. For volume of a rectangular prism, or rather any prism, you're going to have area of the base times the height. And for surface area, these two are actually flip-flop. Surface area of a rectangular prism is 2 times length times width plus 2 times width times height plus 2 times height times length. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . On number 8, we're going to look at how we find the formula for area of a circle. The information that it gives us is the same investigation we did in class where we took a circle and then cut it into pieces and rearranged it to make a parallelogram, or in this case, a rectangle. We already know the area of the rectangle is length times width. And in this proof, they're saying that the width is the radius, which we can see this is your width, and that's the same distance right there. That's the radius. And it's asking why the length of the rectangle is pi times radius. So why did they label this side like they did? And what we can do is actually trace these pieces right here and see that we have 1, 2, 3, 4. And if we do that on the circle, 1, 2, 3, 4, that's actually going to be halfway around a circle. And the distance all the way around a circle is circumference. So if we only want half of that, then we're going to say that that length is half of the circumference. So in words, we can say the length of the rectangle is pi times radius because the length of the rectangle is equal to half the circumference. And then what we're going to do is we're going to prove that that actually works by using the circumference formula. So circumference equals 2 times pi times radius. If we divide that by 2, then instead of 2 times pi times radius, half the circumference is equal to just pi times radius. And for a really complete answer, along with your sentence, you're also going to want to show the math as to where pi times radius comes from. Next, on number 9, we have a running track, and it's made up of 2 straights and 2 semicircles. We need to find the length of each of the straight sections, given that the entire running track is 500 meters. We're going to start by finding the distance around just the curved parts. And with those curved parts, when we put them together, we actually get a full circle. And so for the part that I just labeled in red, we can use our circumference formula. So circumference is 2 times pi times radius. That's step 1. Step 2 is plugging in our numbers. So that's going to be 25 meters for radius. So 2 times 3.14 times 25. That's the same as doing 3.14 multiplied by 50. So that's going to come out to 157, and units for that would be meters. So again, that's just the part in red, and now we need to work backwards to find out what each of these sections would be in green. So to continue, I'm going to take the total distance around, which is 500, and subtract out the 157 to find out the remaining piece. So those two sections together are going to total 343 meters. And to find just one of them, we're going to divide that by 2. So 343 divided by 2. Three, 2 goes into 3 once, and then we're going to have to add a decimal point to have another digit, and 2 goes into 10 5 times. So the total length of the straight section is going to be 171.5 meters. So I'll label each of those sides as X, and that's going to be the total distance of just the straight section. Okay, next, calculate the surface area and volume of each prism. So for surface area, we're going to start with the formula, 2 times length times width plus 2 times width times height plus 2 times height times length. And then I'm going to label each piece. So the length is 6, so we'll label that as L. The width is 3, and the height is 2. So each time we see an L, we're going to plug in 6. So 2 times 6. Each time we see W, we're going to plug in 3. And each time we see H, we're going to plug in 2. And from here, we can do all the multiplication and then add. So 2 times 6 times 3 is 36. 2 times 3 times 2 is 12. And 2 times 2 times 6 is 24. And we can line those up, 36 plus 24 plus 12. And that comes out to be a total of 72. And since this is area, the units are going to be feet squared. Then for volume, the formula we're going to use is area of the base times the height of the prism. To find area of the base, we're going to do 3 times 6, and the height is 2. So 3 times 6 times 2 is 36, and this time it's volume, so we're going to have feet cubed. How many cubes would fit inside of that figure? So volume equals and surface area equals. Next, we're going to find surface area of a triangular prism. I'm going to start by drawing a net, and to do that, I can take this exact triangle right here, 5, 3, 4, with the right angle right here, and that's going to be the top part of my net. I'm going to twist it just a touch, and then I can draw all the rectangles off of that. So it has a height of 8, and then this side has to be 5 since those are going to line up, and each of those are going to need to be 3 with 8 as the height all the way across. And then finally we're going to have one more triangle to represent the other base, which has the same dimensions as the one on the top. Now we just need to find area of each of those pieces. So for each triangle in green, we're going to do base times height, which is 4 times 3, and then for a triangle, divided by 2. So each triangle is going to have an area of 6 square units. So I'm going to label 6 on each of those. Then in blue, this is an 8 by 3, so that's going to have an area of 24. This one in red is an 8 by 4, so that has an area of 32. And last one is 5 by 8. That's going to have an area of 40. So I'm going to circle all my areas just so I don't confuse them with side lengths. Now I can go ahead and add those up. So 6 plus 6 plus 32 plus 24 plus 40. And that's going to come out to 104, and this is in feet, so that's going to be feet squared. Then for volume, I'm going to show the 4 steps. This is going to be still area of the base times the height of the prism. This time, we've got our triangle for the base. We already found over here that the area of each base is 6, so I'm going to go ahead and use that again. So remember that was 4 times 3 divided by 2. And the height is the one that connects the two bases, so the height is 8. So for volume, I'm going to get 6 times 8, which is 48, and that's going to be cubic feet, so feet to the 3rd power. Next up, a rectangular prism has a surface area of 148 inches squared. The length is 5 inches, the width is 4 inches, and we need to find the height. So let's start with the formula and work our way backwards. And we know the surface area, so I'm going to plug in 148 underneath surface area. We know the length is 5, so anytime I see L, I'm going to put 5. and the width is 4. So every time I have W, I'm going to substitute 4. And then to continue everything else, I'm just going to bring down the pieces we haven't used yet. So all the 2's, multiplication, addition, and the heights. From here, I'm going to combine the like terms that I can. So 2 times 5 times 4 is 40. I'm going to bring down 148 equals, plus 2 times 4 times h is 8h, plus 2 times 5 times h is 10h. Then from here, still combining like terms, 8h plus 10h is 18h. We still have positive 40 equals 148. And now it's a two-step equation. So we're going to subtract 40 from each side. Here's my 0 pair. And we'll get 108 equals 18h. Finally, we're going to divide by 18 on each side. So 108 divided by 18. And 18 is going to go in exactly 6 times. So for our final answer, we're going to get 6 as the height, and we're going to include our units, which are inches. So 6 inches equals the height. A rectangular prism has a volume of 960 cubic centimeters. We have a width of 8, a height of 12, and we need to find the length. So just like before, we're going to use our 4-step process. Volume equals area of the base times the height of the prism. We can also sketch this out if we have a height of 12 and a width of 8. We're trying to find the length right here. So area of the base is going to be this rectangle right here. So area of the base is going to be 8 times length, and then the height is going to be 12, so times 12. From here, I can combine 8 times 12, and then I get 96 times the length. It also told us what the volume was, so actually instead of volume, I can substitute that with 960. And then to solve 960 equals 96 times L, I'm just going to divide by 96 on each side and get a length of 10. And then finally, I'm going to substitute in measurements. So final answer is 10 centimeters. Number 13, a circle has an area of 254 and 34 hundredths square meters, and we need to find the radius. So working backwards, we're going to start with the formula for area of a circle, which is pi times radius squared. And then in step 2, I'm going to substitute in all the things that I know. So the total area is 254.34. The value for pi is 3.14. And I don't know what the radius is yet, so I'm going to multiply by radius squared. Then I'm going to divide by pi on each side, so divide by 3.14. So I'm going to set up the division box, 254.34 divided by 3.14. Remember, you can't divide by a decimal unless you move the decimal point over 2 spots, so multiply by 100 on both of these numbers. And that's going to turn it into 25,434 divided by 314. And when I work out the division, it comes out to 81. So on the left-hand side, we have 81. And on the right-hand side, we still have radius squared. So we need to figure out what number times itself equals 81. The mathematical way to show that is the square root of the radius and the square root of 81, which gives us 9 for the radius. And then finally, I'm going to put units on that. So we'd have a radius of 9 meters. Okay, final one. A circle has a circumference of 56.52. What is the radius? We're going to use our circumference formula, and we're going to use the one that uses radius. So circumference equals 2 times pi times radius. In place of circumference, I'm going to substitute 56.52 and then bring down 2 times 3.14 times radius. And then we can solve for r to get our answer. I'm going to combine 2 times 3.14 to get 6.28 times radius equals 56.52. And then I'm going to divide by 6.28 on each side. Just like before, set up your division box. 56.52 divided by 6.28. And then we're going to multiply by 100 on both numbers to get rid of the decimal on the number we're dividing by. So 5,652 divided by 628. And then when we work that out, that actually goes in evenly 9 times. So we get a value of 9 equals the radius. And then we're going to put units on that, which would be miles. So 9 miles is equal to the radius. Once again, be sure that you have corrected all of these answers with a grading pen, starred the correct answers, and just to see who's listening, go ahead and put a star in the upper right-hand corner of the second page. Thank you for watching, and good luck on your test.